Hey guys, let's do this problem right here. It's asking determine the normal force, shear force, and the moment at point C. So since we have this diagram, so first of all we had to mention the forces right here. So this is going to have two forces, By and Bx. We don't know the direction, we can just assume and solve for this one. So this is going to have only the vertical direction, it's going to be Ay. So since we have two unknown in here and one unknown here, it's easy to find the Ay first by taking the moment around B. So if I take moment around B, I will eliminate these two, so I can find the Ay. If I take moment around B equal to 0 in statics, and if I take counterclockwise positive and solve for this one, I will get um, 10, 10 kilonewton acting downside here, it's 1.5. Therefore, it's pushing this object uh, so this is pushing this object clockwise, right? This is clockwise, so it's going to be minus 10 times 1.5. Then Ay is pulling this object also clockwise, so it's going to be Ay times 3, and it's going to be negative Ay times 3. Also we have 30 kilonewton meter, that's directly a moment, and they have given it's acting counterclockwise, so it's going to be positive 30, and that's all we have, so equal to 0. So if I solve for this one, I will get Ay is equal to, so this is 15, right? Negative 15 plus 30 is going to be negative plus 15, plus 15 and divided by negative 3 become negative 5. So since let's make sure again. So if I take this one, negative 30 plus 15, so it's going to become negative 15, and it's plus 5 kilonewton. So it means our direction is right, and that's it. Then what you have to do, the main question is find determine the normal force, shear force, and the moment at point C. So since we have found the Ay already, we can cut this part into half like this, and I draw this part separately. It's going to be something like this. So we are going to have Ay in the middle. So we found it's 5 kilonewton and 30 kilonewton meter acting counterclockwise, 30 kilonewton meter. And also we are going to have normal force here, Na, and let's assume we don't know the direction of the shear force, but we can assume and solve for this one, because if we get negative answer, it means the assumption is wrong and we can correct it. So since we have this direction, I can take this is going to be BC, and normal force, shear force, and the movement around C. That's all we have to find. So first of all, it's easy to find Na, because that's the only horizontal force right here. So I can, if I take summation of f of x equal to 0 in statics, and if it takes this direction positive and solve for this one, I will get Na is equal to 0, because we don't have any other horizontal force acting on this object. So I can directly say this is equal to 0, and then if I do summation of f of y is equal to 0 and take upper direction positive and solve for this one, I will get 5 kilonewton acting upside, so it's going to be positive, and we have Vc acting downside, so it's going to be negative Vc equal to, those are the only two vertical forces we have, so equal to 0. So if I solve for Vc, I will get 5 kilonewton, so it means the direction is right. This is the direction for this Vc. And then final question is asking to find the moment around C. To calculate moment around C, yeah, I had to take moment around C. So if I take MC is equal to 0 and solve for this one, I will get this is acting counterclockwise, right? So it's going to be, so C, so this is acting counterclockwise, this is going to be positive 30, and we have Ay pushing this object clockwise, and we know the Ay already, so it's going to be minus 5 times 1.5, and these are the only two forces, gonna two moments we have, and plus let's assume MC is acting counterclockwise, so you can take clockwise or counterclockwise for MC, because at the final answer it depends on the final answer, because if you get negative, you're gonna that sign is going to change anyway, right? So if you get positive answer, it means the object is acting counterclockwise. If you get negative, it means the object is acting clockwise. So if I solve for this one, I will get 30 minus 15 is going to be positive 15, and if I take to the other side, it's going to be negative 15. So no, this is 5 times 1.5. Okay, 5 times 1.5 is 7.5, so it's going to be 22.5. 7.5 is going to be positive 22.5, and in this case it's negative 22.5. If I take to the other side, kilonewton meter. So we know this, since sign is negative, I know this is acting in the clockwise. So if you put negative, it's automatically mean that it's acting clockwise, or you can mention the direction MC is equal to 22.5 kilonewton meter clockwise. So this is my final answer. So we have found normal force. Normal normal force is equal to 0. Shear force and moment at point C. So that's the question. I hope you guys like this video. See you next time.